Yes, hello everyone, how are you all? I hope that all of you are doing super amazing. Okay, welcome to today's session. Good evening, everyone. I hope you all are doing good. I hope you all taking care of yourselves. Is it so? I can't see the chat. 1 minute, just a second. Yeah, let me just open and yes, now I can easily see the chat. So, how are you all? Okay, good. That's awesome. So, people, what we'll be doing today is your electricity part 4. A very important chapter, and 3 parts have already been covered. In case you've missed those parts, go back and watch all the amazing sessions which have been already uploaded. So today is the 4th part of electricity, and the agenda for today is something very simple. Circuit diagrams. First we'll be understanding what are circuit diagrams and about the resistors in series, which is your combination. Okay, two combinations are there, series and parallel. So in today's session we'll be focusing on this series combination, right? In parallel we'll be doing the next session along with PYQs, the previous year questions from this particular topic. Right everyone, so let's understand the circuit diagrams now. So see, first of all you should be able to understand that what exactly is a circuit diagram. Actually, a circuit diagram is a representation of a circuit. Like even we can understand, we cannot just make the real bulb or the real cell or battery, because that will be very tough and time consuming. So to make it a little bit easier, we use circuit diagrams, which is the schematic representation of a circuit, of a real circuit. And I hope you are already aware of the different components that we have. How many of you are aware? We have different components, like I can say a cell, a battery, cell or battery we can say. We will have a switch. We will also have the electric current flowing. How do we do that? I will tell you. What are the different symbols? I will tell you. These are some of the components of any electric circuit. Okay. Now see, some of the very important components. First thing, electric cell. So how do we draw? Just a second. Yeah. How do we draw an electric cell? In this manner? So you can draw it like one positive terminal, one negative terminal. In this manner you can draw. Battery is a combination of cells when different cells are combined. So you can see 2 or more cells are there. Then we have plug, key or switch. Plug, key means you can say the switch. Earlier you must be making in a different manner, but this is the open switch. In this, electric current is not going to flow, and this is the closed switch. You have to draw in this manner, where your electric current is going to flow. Now a wire joint, generally a wire is this, a straight horizontal line. Okay, then wires crossing without joining. So this will be your diagram for this. Electric bulb, either you can draw in this manner, simple, or you can even draw somewhat in this manner. Okay, your filament and all that you can match. Now a resistor of resistance R. How do we draw the resistance? For resistance we have this. You can see this kind of zigzag for resistance. Right now, variable resistance or rheostat, variable resistance when resistance can vary. So for that we have this kind of a symbol which is there. You can say an arrow. Okay, and for rheostat we have this symbol, as you're able to see. Okay, this symbol is for your rheostat. Then your ammeter is simple A, simple A, and voltmeter is simple V. Positive, negative, positive, negative. And always remember, in this chapter you will be asked to draw many circuit diagrams. You will be asked to draw many circuit diagrams, as well as you will be asked to do a lot of calculations with the circuit diagram. So always remember that you have to draw the circuit diagram very neatly. Neatness is very important. Okay, you'll keep in mind. Now with this, let's move to resistors in series. So before that, let me tell you that there are, you can say, two combination. Whenever we want to combine any, you can say, the resistances, or I would use a word over here, whenever I want to combine resistors, whenever I want to do that, I am going to do it in two manner. What are the two ways? In series or in parallel. Two ways are there to combine both of them. What is series now? How do we actually combine them in series? That let's understand that. Now see, whenever we are combining resistors in series, resistors is going to be something which is going to give you resistance, which is going to oppose the flow of current that we've already discussed, right? See, now understand, when two or more resistors are connected end to end consecutively, they are said to be in series combination. What do I mean by end to end connection? Okay, 1 second, sorry. End to end connection means, like, suppose I have this resistor. Okay, now from this end only I am going to connect another resistor, and it can be like whether you connect 2 resistors, 3 resistors, if you're going to connect them end to end, then they will be in series. Like, you can remember it by your cricket matches. You have a series, so after one match you have another match, after the second match the third match, the fourth, after the third the fourth match. So it happens in a series. Same here, after one resistor another resistor, then another one. So this system is your resistors in series. Now what is something which you have to learn is current is constant. The current which will flow, that is, you can say, your I, that will remain constant, but your potential difference will be variable. This can vary. Current will remain constant throughout the circuit, but your potential difference will be variable. It can vary, it can change. Clear? Now, let's derive the mathematical expression for this. How do we get the mathematical expression? That is very, very important. So eyes on your screen, because this will be very, very important. Until I would just say, whenever you are making circuit diagrams, remember these. You can just go through it once, because this will help you in understanding. Okay, fine. Now let's try to derive the mathematical expression for this. So you already know that in your series combination, your current remains constant, right? But your potential difference is changing. So if I write current, then it wouldn't make sense because it is the same. So using current as a value wouldn't mean at all. So what do I use? I use potential difference. So your potential difference will be equals to V1 plus V2 plus V3 or not. V1 is your first device, then V2 is the second one, and V3 is the third one, end to end. So they will be added. Okay, whenever we are deriving, we are going to add all the resistances, but how we are going to get till there, that is going to be more important. Now you know V is equals to V1 plus V2 plus V3. Now according to Ohm's law, you already know that V is equals to IR, right? So I can say that instead of V, I can write IR or no? Definitely. So I can write IR is equals to IR1 plus IR2 plus IR3. I can definitely write this, correct? Now till infinity, I can say IN. N is till any number, because remember in series, if we want to find the total resistance, we always add all the resistances. Like in this circuit, suppose I'm drawing a circuit. In this I have two resistances, so they are connected in series. So if I want to find the total resistance, then I am going to add both of them, that is R1 plus R2. Clear? But then now let's derive the mathematical expression, that is more important for now. So then you can, oh my god, what have I done by mistake? Chalo, let me write once more. V is equals to V1 plus V2 plus V3. According to Ohm's law, V is equals to IR. So instead of V, I can write IR. So IR is equals to, by mistake I erased, okay, IR1 plus IR2 plus IR3. Right. So now the point to be understood is that you can say, can I take I in common? Because I is the same. You know that current flowing in the series combination will remain the same. So I can definitely take I in common. So I can say R is equals to, now see, I am taking I in common. Chalo, let me open only. Then what am I left with? R1 plus R2 plus R3. R1 plus R2 plus R3. I am left with this now. Clear? Now you can see that I to I can get cancelled easily. Yes. Now what you're gonna get? Now you will get R is equals to R1 plus R2 plus R3. So till you can say Rn, any number of resistances. This is your mathematical expression. Learn it by heart. R is equals to R1 plus R2 plus R3. Clear? This is your mathematical expression. Now in series, in series combination, total resistance of combination of resistors is equal to the sum of their individual resistances. What do I understand? It means your R equivalent. What is R equivalent? Your total. I represent it by Req. That will be equals to the sum of the individual resistances, that is R1 plus R2 plus R3. So these three resistances are gonna give you R equivalent, that is your total resistance in the particular circuit. Like for example, I have this circuit, although it's not that neat, and here there is a end-to-end connection. Okay, now suppose this is 5 ohm, this is 6 ohm, this is 7 ohm. Three resistors have been connected. Now right now I'm not drawing the complete circuit. We are going to do one question. So you are able to see, if I want to find the equivalent resistance, that is your Req, or the total resistance, what will I do? I will add all the resistances. So I am going to add 5, 6 and 7. That will give me 7 plus 6, 13. Okay, and 13 plus 5, 18 ohm. So this is your equivalent resistance, or you can say the total resistance. And always remember that in series combination, R equivalent is maximum. Okay, so if you want maximum resistance in any circuit, then you will connect it in series combination, because the resistance, the equivalent resistance is going to be your maximum and more than the individual resistances. You by here only are able to see 18 ohm is more than 5 ohm, 6 ohm and 7 ohm. Okay, so this is something about your series combination. Now let's solve a question related to it. The question says calculate current in the given circuit. So this is your circuit and you are asked to calculate the current. Now focus over here. You know whatever is given to you. What is given to you? See, your potential difference, positive, negative. I forgot to add that. See, this is a circuit. In this manner, you will also have to draw different circuit diagrams. So 220 volt battery is there. Okay, this is the battery of 220 volt and this is your potential difference, 220 volt. Now three resistors are there of 5 ohm, 6 ohm and 9 ohm, and you are asked to, and it is a closed circuit, it means electric current is flowing in it. So now you are asked to calculate current. How are you going to calculate the current? See, first of all, you should be able to calculate the resistance. So what is your equivalent resistance, total resistance in this? As it is series, R1 plus R2 plus R3. Correct. In parallel, remember, it will be opposite. That we'll be doing in the next session. Probably you can check out the upcoming live streams if you want to know this. Okay. So your R equivalent will be equals to R1, that is 5 ohm, R2, that is 6 ohm, R3, that is 9 ohm. So what is the total? 9 plus 6, 15 plus 5, 20 ohm. So this is your equivalent resistance. And you know that your potential difference is 220 volt, right? And you also know that according to Ohm's law, V is equals to IR. So I is equals to V upon R. You have the value of R, you have the value of V, just substitute. So your I will be equals to 220 by 20. 0 to 0 got cancelled. 11 times 2 is 22. So your I is equals to 11 amperes. So the current flowing in the circuit is 11 amperes. I hope this question is super duper clear, and there are many more questions framed. Like for example, you may get a question. I don't have space over here. Okay, just a second. Yes. So you may get a question on finding the voltage, maybe. Okay. You might get a question related to resistance in such cases, but most probably you will get the current one, because current is constant, potential difference will vary. That we will read in parallel combination when potential difference will be constant, so you will be asked to find out the potential difference. Okay, but for now you should be able to calculate the total resistance, that is your R equivalent, R1 plus R2 plus R3 till Rn. If you have 10 resistors connected in series, so add all of them. This is easier than parallel one, because in parallel we do the reciprocal, that I will be teaching you in the next session. Okay, and for now, just remember, have confidence in yourself and you will be able to crack. Thank you so much for attending this session. Before ending the session, I would like to give you few tips for solving the questions. Now, many of the times in board exams, you get circuit diagram based question. Either you have to analyze the diagram, either you have to analyze the diagram or you have to make the diagram, you have to draw it by yourself. And how do you draw? I have told you, remember, a common mistake that children do not make this arrow. This arrow indicates flow of current, and it is in one of the exam. I would tell you, a student did not mention this arrow. His circuit diagram was perfect, but he forgot to mention this arrow, and do you know what happened with him? He got 0 marks, because this arrow was missing, which indicated the flow of current. And if he's not writing, it means circuit is open. Either circuit is open or it is not working, which will give you the wrong answer. If current is not flowing, the circuit is nothing, means you wouldn't get full marks. So that is why that child also did not get. But if you want to get full marks, then do not forget to make this arrow very, very important. I hope that's clear, as well as you should make sure that your circuit diagrams will be very neat, very clean, and probably you will get full marks in your exams. Okay, so thank you so much for today's session. Now, I did not check the live chat today. I would like to check. Just a second. Let me check the live chat. I know this topic was a little bit easy. In the next session, we'll be having a lot of numericals as well. In today's session, probably we couldn't have much numericals, only one numerical we had, and that too was quite easy, isn't it? What are your views on this? Hi, fantastic warriors. Hi, Hindi and French. How are you all? So I think now we should end this session, because we'll be meeting in the next session with a lot of fun again. So Do not forget to like, share and subscribe to the channel. Okay guys, and now I'm ending the session for today. Bye bye all of you. Okay, and I hope you enjoyed as well. And another, remember that you have to get full marks during your exam. Those of you who've joined right now, you can go back to the video, watch it completely for getting full knowledge as well as full marks. Okay, so bye bye and take care everyone.